Hey guys, so we're going to talk about some part whole and how to use it to solve word problems. So the biggest thing to remember when we're using part whole and using it with a bar model is it is not there to help us solve the actual math. You have to do something else to do that. It's not going to help you add, it's not going to help you subtract, multiply, or divide. But what part whole does it helps us figure out or determine what the equation is going to be.
Teachers.
So it's not going to help you necessarily solve the problem, but it's going to help you determine what that equation is so that you can...
Okay, Steph.
Alright, so we're going to look at some examples. So if I am using the part whole with bar model, we're going to use that to solve this word problem so you can see what that looks like. So the problem reads, there are 3 students on the bus at 3:15. At 3:30, 4 more students get on the bus. How many students are now on the bus? If I'm looking at my question portion of this word problem, it's going to help me determine what it is I'm supposed to be counting and solving for. How many students are now on the bus? That tells me I'm going to be looking at students. That's what I'm counting. So I'm going to go ahead and draw my bar model. The entire part of my bar, or my whole, is the total number of whatever it is I'm counting. I'm counting students. Based on this problem, if I read it again, it doesn't tell me the total number of students on the bus. It tells me some got on this time and some got on another time, but it doesn't tell me how many total. So down here I'm going to put a question mark. I have 2 different times in which people are getting on the bus. So I'm going to split my bar into 2 different sections. So my first section is going to be my 3:15 time. I'm going to put a 3 in that box. And I'm doing that because that's the number of students, who got on at 3:15. Now, at 3:30, 4 more got on. So my other box is going to represent that 3:30 time, and I'm going to write a 4 in it. Now, from here, each of my boxes, my smaller boxes, represent my part. So in this problem, I have 2 parts, and then 1 whole would be the total parts all pushed together. So to solve this problem, would be part plus part equals whole. So if I put that in context of my bar model, I have 3 as 1 part, plus 4 as my other part, equals my whole, which I don't know. I can solve that as 7 equals my whole or my box or whatever you want it to be, question mark. So the total number of students on the bus is 7. That is how I went from a bar model and made it using part whole into an equation. So let's do another one, slightly different version. This one says, Miss Miller made 24 cookies. She ate 2 of them for breakfast. Breakfast of champions. How many cookies does she have now? So again, I'm looking at that question portion of my word problem to figure out what it is I'm counting. How many cookies? I'm counting cookies. So I'm going to draw my bar. Start with the whole. Do I know the total number of cookies? Actually, for this problem, I do. It's right in that very first sentence. Miss Miller made 24 cookies. So down here by whole, I'm going to write 24 because I do know the total amount. I know that I ate 2 of them for breakfast, so I'm going to partition my bar. And I'm going to put 2 in that first section because those are the 2 that I ate for breakfast. I don't know how many I have left. So that's going to be my question mark, or I can just leave it blank. So that's what it's asking me. How many do I have left over? So to turn this into an equation, I can use a couple of different options. So if I use the same part plus part equals whole model, I'll just fill in the different pieces that I know. So I know one piece is 2, it's one of my parts. My other part is question mark, I'll make that box, equals my whole, or 24. I can also do a subtraction equation with this. I just have to use a slightly different formula. So when I'm subtracting using part whole, I always start with the total amount of things, which makes sense, right? If I'm going to take away something, I have to start with all of the things, then I can start subtracting out. So when I'm subtracting using part whole, I start with my whole, I subtract one part, and I get the other part. So if I'm using this equation builder, I'm going to start with 24 minus, now I can use either part. I could use the 2 or the box, they're both parts. But to make this equation easier, I'm going to go ahead and put in the 2. That way I have something to actually subtract. Equals box. Both of these equations will solve this problem. It's just on how you look at it. But as you can tell by now, the answer is 22. So 22 cookies I have left. So I definitely want you to write this part down. I know we've gone over it, or maybe we haven't gone over it yet. But what does part whole look like to solve an addition versus a subtraction problem? So we've just looked at that in our last problem, but addition part whole is going to be one of the parts plus another part equals the total. And this could be more than one part as well. Like if we had part plus part plus part equals whole, that would still work. You just have a couple of different parts. With subtraction, like I just said, you're going to start with the whole first, the total amount of things first, then you're going to subtract out the part, and what you have left is the other part. So go ahead and write the addition and subtraction part wholes in there if you have not done so already, and that'll be the end of our video. So go ahead and continue on with your learning path.